So now that you have that, the last part of this algorithm is just going to be you essentially take these two lists and you get a new list with the minimum value at each position. So if I were to do this, my new list would look like what? Well, the first position, the minimum of 0 and 0 is just 0. The minimum of 1 and 1 is 1. The minimum of 0 and 0 is 0. For the fourth position, the minimum of 0 and 1 is 0. For the fifth position, the minimum of 0 and 0 is 0. And for the last and sixth position, the minimum of 2 and 1 is 1. Now, the way you would do this is that you use this newer fancy map block we talked about, that once you click this black arrow, it can take two lists, and you put these lists next to each other, because this way the map will compare the corresponding positions of the list. And the function that you would map over these lists is a minimum function. So a function that takes in two numbers and finds the minimum. And that's not given to you in Snap, so the easiest way to do it is to code it yourself. It shouldn't take too long. So once you've done that part of the algorithm, you notice that you have this list 0, 1, 0, 0, 0, 1. Again, you can use one of the higher order functions, and the goal is simply to combine this in, that may have been a hint there, but to combine this into one value. You want to sum up all of these values, and you want to have a final value equal to 2. Because once you have that, you, if you recall, have gotten the number of out of place letters that you had in VVOG and in GOVG. Let's talk about in the next video as a summary why this exactly works, why this algorithm doesn't error, and why it gives us the answer that we want.